Hello everyone, welcome to BYJU'S Exam Prep, the most comprehensive preparation app for all exams. Good evening all of you and welcome to another session of this Mastering GATE Concepts for GATE 2023. And today we are going to cover the previous year questions based on synchronization. So guys, before starting, I would request to all of you to kindly share this class as much as you can so that we can have maximum students and they can take the benefit of this class. Yes, everyone, do share the class. Good evening all of you. So today we are going to solve some previous year question based on synchronization. In every session, before this session also, I have taken the concepts as well as we have solved the previous year questions. But today we are going to solve some more previous year questions based on the concepts we have learned so far in this series and in this topic synchronization. So am I properly audible and visible to all of you? Please confirm once in the chat box, guys. Yes, everyone. And guys, do share the class as much as you can so that we can have maximum students and they can take the benefit of this class. Good evening Tushar, how are you guys? Do like the session. Those who have joined just now, do like the session, share as much as you can. Okay, so let's start PYQs on synchronization. Before starting, let me introduce myself, those who are not. Yes, so before starting, let me introduce myself. My name is Anshul Sharma. I have 2+ years of experience. In GATE 2020, I have secured All India rank 294, cleared ISRO and NILET exam, mentored more than 1,000 students as of now, and these are my area of expertise: operating system, digital logic, compiler and COA. Known learner, you should be, yes, thank you Tushar. You should have some patience, okay? You cannot prepare everything very fast, right? If you want to attend, otherwise you can leave the session. Okay, fine. So here BYJU'S Exam Prep, we have started this Mastering Concepts for GATE 2023 free online YouTube course for all these branches: mechanical, civil, computer science, electrical and electronics communication, and these are going to be the timings for the classes. So don't miss it. For computer science, you can attend all the classes. The next series that is going to start, in this series, the next subject that is going to start is C programming and data structure. Okay, so there is one more session that will be taken by our dear Abhinav Negi sir. So he will be taking this session, how to ace GATE 2023 in first attempt. So on 27th of March, 12:30 PM, only on BYJU'S app. Okay, BYJU'S Exam Prep app. So this is the first question you have, guys. Yes, everyone, try to answer this question and let me know what should be the answer. And guys, keep sharing the session as much as you can. Yes, what should be the answer, guys? So this question is based on dining philosopher problem that we have already discussed in the previous class. Okay, and all questions are previous year questions. Okay, so we are getting the answers now. Minakshi is saying option C should be correct. Okay, yes, so in the concept we have also discussed that there is a case where we can have deadlock in dining philosopher problem, and I also explained what are the possible solutions we can have to avoid such possibility of deadlock. Okay, so let's read the question here. A solution to the dining philosopher problem which avoids deadlock is, option A is, let's ensure that all philosophers pick up the left fork before the right fork. But that is a case where we can have the deadlock, right? That is the case where we can have the deadlock. So obviously this is not going to avoid the possibility of deadlock. What about option B? Here it is saying the vice versa of it. First pick the right fork and then the left fork. Here also we can have the possibility of deadlock, right? What about C? Ensures that one particular philosopher picks up the left fork before the right fork and all the other remaining philosophers will pick the right fork before the left fork. Yes, this is the one of the possible solution of avoiding the deadlock. So option C is the correct answer. Meenakshi and Tushar, your answer is absolutely correct. Very good, guys, very good. Okay, so let's proceed to the next question now. Try to answer this question. Yes, everyone. Read the question carefully and let me know what should be the answer, guys. And share this session as much as you can, because we are solving previous year questions and every question is going to be very important to understand the concept, to understand the approach. Okay. Yes, try to answer this question. I hope the question is visible to you. Yes, what should be the answer, guys? Read it carefully. Given below is a program which when executed spawns two concurrent processes. Okay. So we have two processes, P1 and P2. Now the initial value of semaphore, that is x is equal to 0. Initial value of semaphore is 0 here, right? And we have to find which of the following statements is or are true. So first statement is it is possible for process P1 to starve. Second is it is possible for process P2 to starve. Yes, which will be the correct answer here? Which statement is true and which one is false? Or both true, both false? Yes, guys. Try to answer this. Let's see how many of you will answer this correctly. Anyone getting the answer for this question? Tushar is saying option A should be the correct one. Okay. Anyone else? Okay, let's see this question. Let's understand this question, how to solve it correctly. Okay. So we have a program where we have two processes, concurrent processes, okay, process P1 and P2. Consider the following statements about process P1 and P2. First statement, it is saying it is possible for process P1 to starve. Second one is for process P2 to starve. So we have to find which of the two processes will face the starvation here, or there is a possibility. So let's see here, initial value of a semaphore that is given, it is a 0. Right, it is a binary semaphore. Clear? Now let's see the code here. So we have P2 code, repeat forever px, compute and vx. P1 is repeat forever v of x, compute and px. Now if you carefully see, let's execute P1 process. So what P1 will does? P1 is going to signal the value of x. So it is going to make it 1, compute, find. P of x, it is going to make it 0. Now let's say if P1 tries to execute again, yes, it can execute again v of x, it is again going to signal the value of x, right, compute and again P of x, so it is going to make it 0. That means yes, there is a possibility where P1 can again and again execute its code without letting P2 to execute the code. It is the possibility. Yes or no, everyone? Right? So this is the possibility here that P1 can execute again and again and P2 will face starvation. So it is possible for process P2 to starve. Yes, this is true. Yes, definitely it is possible that it can face starvation. Okay, Meenakshi is saying option C should be correct. Okay, let's see. Now let's see whether P1 can face starvation or not. So carefully see, let's execute P2. Try to execute P2. Initial value is a 0. P of x, it will not be able to proceed further. That means at any cost we have to start with process P1 only. Now let's say P1 executes V of x. It is going to signal the value of x. It is going to increment it. Now let's say it got preempted. Just consider one case where it got preempted. Now come back to P2. P of x, yes, it will perform wait operation. Compute, yes, V of x, it will make it 1. Now you have the possibility where, because value of x is 1 now, so you have the possibility where P2 can execute again and again, and in this case it is possible that P1 will face starvation. P1 will not be able to proceed. Even if you see, let's say P2 got preempted and here compute. Okay, here compute, and let's say P2 is here, compute, then P of x. Already P of x is performed by P2. So let's say already P of x is performed by P2. That means P2 is present here. It is about to execute this compute, right? Whatever is the operation here. Now it will get blocked here. It will get blocked here. Now P2 will perform V of x. It will make it 1. And now again P2 has the chance to execute. That means there is a possibility where both the processes can face starvation. Is it clear? Both the processes may face starvation. So yes, statement 1 is also true here. So which of the following holds here? Option A is the correct answer. Both first and second are true here, because we just have to find out the possibility, and yes, we have seen that there is a possibility where both the processes can face starvation. Fine, so let's try to answer this question now, everyone. Yes, Meenakshi. Very good, Tushar. You are doing good. Guys, share the session as much as you can in all the Telegram and WhatsApp groups and try to solve this question. So here in this question, we have two processes P1 and P2 using critical flag, right, in order to achieve mutual exclusion. Critical flag is initialized to false in the main program. Now again there are two statements given to you and you have to find which one is true, which one is false. Yes, all of you try to solve this and let me know what should be the answer. Anyone getting the answer? So this is the code given to you and you have to find which of the following statement is or are true. First statement is, it is possible for both P1 and P2 to access critical region concurrently. That means there is no mutual exclusion. And second one is, this may lead to a deadlock. Meenakshi is saying option C should be the answer. Okay, let's read the question. Processes P1 and P2 uses critical flag. Okay? Critical flag initialized to false. Now, let's try to find out whether we have the mutual exclusion satisfied here or not. So, as you can see, critical flag initial value is false here, right? Get exclusive access, fine, if critical flag is equal to false. Let's say we are talking about P1 process first. P1 is trying to execute critical flag is equal to false. So initially it is false. So this situation, this condition, if condition will become true. Now as it becomes true, let's say just after this one, P1 got preempted. Just after checking the condition, if condition that it is true, P1 got preempted. Now let's talk about P2. P2 will also execute this. It will also check whether this if condition is true or false. Initial value is false. False is equal to false. Yes, it is true. That means for P2 also it becomes true. Now P2 further executes. Critical flag is equal to true, so it makes it true now. And critical region. So P2 is present here. Now let's say P2 got preempted here, and now again we are talking about P1. So already P1 has checked this condition, if condition, and for this P1 process this condition is true, right? So it is going to execute from here onwards. Critical flag is equal to true. Already it is true. It is just going to overwrite it. Critical flag. So that means P1 is also present here. Are we having mutual exclusion here? No. Mutual exclusion is not satisfied here because both P1, P2 processes are able to access the critical region at the same time, right? So first condition is statement is it is possible for both P1, P2 to access critical region concurrently. Yes, it is true. Yes, it is true. Second, this may lead to a deadlock. Now we know this that one of the condition for deadlock is mutual exclusion, correct? As you can see, this statement is indirectly saying that mutual exclusion is not satisfied. So if mutual exclusion is not satisfied, is it true? So can we have a deadlock? No, because if you dissatisfy one of the condition of deadlock, then you cannot have deadlock, right? So mutual exclusion is not satisfied, you cannot have deadlock, so this is going to become false. This will be false here. So you can see statement 1 is true, statement 2 is false. So accordingly option C is the correct answer here. Yes, Meenakshi, your answer is absolutely correct. Is it clear to all of you? If you have any doubt, guys, please ask. Let's proceed to the next question now. Question number 4. So there are two processes, P1 and P2, and they are sharing a variable B with an initial value 2, with an initial value of 2, and they are executing concurrently, okay? So you have to find the number of distinct values that B can possibly take after the execution of both these processes. So all the possible distinct values of B you have to find out, and you have to find the number of those values. Yes, everyone try to solve this and let me know what should be the answer. Okay, Meenakshi is saying 4, 3, 2. That means 3 values according to you. 3 distinct values. Okay, fine. Anyone else getting the answer? Tushar? Anyone else? Okay, fine. See, let's solve this question. So here, if they are executing concurrently, there are some possibilities here. Let's see the first possibility. First possibility is, let's say, first P1 will execute completely and then we are going to have P2. This is one of the possibility. Second possibility is, first P2 is executing completely and then we are having P1. Third possibility, first P1 executes, then we are having P2, and then again we are having P1. That means, let's say first statement of P1 executes, then P2 completely, and then second statement of P1. Possible? Yes. And then other possibility also we can have, let's say P2 here, P1 here, and P2 here. That means first statement of P2, then entire P1, and then the second statement of P2. This is also one of the possibility, correct? We can have 2 more possibilities here. First statement of P1, first statement of P2, second statement of P1, second statement of P2. Similarly, vice versa. P2, first statement of P2, first statement of P1, second statement of this P2, and second statement of P1. So let's try to find out in these cases what do we get. Okay, so first case, P1 first and then P2. Initial value of B is 2 here. So C is equal to B minus 1. C will become 1 here. B is equal to 2 into C. So B will become 2 into C, that means 2 only. Now P2 process executes. D is equal to 2 times B. 2 times B, that means 4. B is equal to D minus 1, that means it is 3. So in this case we are having 3 as the value of B. In this case we are having 3 as the value of B. What about this one? D is equal to 2 into B. So D is equal to 2 into B. So B value is, initial value is 2 here. So D will become 4. And then we are having B is equal to D minus 1, that means 3. Now P1 will execute. C is equal to B minus 1, that means 2. And B is equal to 2 into C, that means 4. So we can have 3, we can have 4. So far this is possible. Clear? Now let's consider this case, P1, P2 and then P1. So first statement of P1 executes, B minus 1, that means 1. Then entire P2 executes, D is equal to 2 into B, that means 4. B is equal to D minus 1, that means 3. And then B is equal to 2 into C. B is equal to 2 into C, that means 2. So 2 is also possible, 3 is also possible, 4 is also possible. Let's try this case as well. P2 first, D is equal to 2 into B, that means 4. Now entire P1 executes. This is going to become 1, B minus 1. Then B is equal to 2 into C, that means 2. And B is equal to D minus 1, that means 3. So 3 already done. So 2, 3, 4, these are the possibilities. Yes, your answer is correct. So 3 distinct values we are getting, that is 2, 3, 4. These are the distinct values we are getting. Yes, that is correct. Very good, Meenakshi. Your answer is correct. Let's proceed to the next question now. Yes, try to answer this one. Read the question carefully and then try to solve it. And guys, keep sharing the session and do like it if you haven't liked it yet. What should be the answer for this question? Anyone getting the answer? Yes. Let's read the question first. A multi-threaded program P, that means there is a program P which can have multiple threads, okay, executes with X number of threads, uses Y number of locks for ensuring mutual exclusion while operating on shared memory locations. Fine. That means we have one program P which can have X number of threads and Y number of locks. All locks in the program are non-reentrant. What is non-reentrant? That is, if a thread holds a lock L, then it cannot reacquire lock L without releasing it. So let me tell you one case here. If we talk about first reentrant, here it is mentioned non-reentrant. Let's talk about reentrant first. In case of reentrant lock, if the lock is reentrant, then a program or a thread, let's say a thread, it can acquire the lock again without releasing the previous lock. That is the meaning of reentrant lock. Here it is mentioned that it is non-reentrant. That means once it has acquired the lock, before releasing the previous lock, it cannot acquire again. That is the meaning of non-reentrant. Now there is one more thing mentioned here. If a thread is unable to acquire a lock, it blocks until the lock becomes available. Okay, so here it is saying if a thread is unable to acquire a lock, it will get blocked till the lock I'm sorry, till the lock becomes available. The minimum value of x, that means the number of threads, the minimum value of y together, for which execution of p can result in a deadlock are. What should be the minimum value? Yes, what should be the minimum value of x and y so that it can result in deadlock? Meenakshi is saying option D should be correct. Okay. Anyone else getting the answer? So here we have to find the minimum value of x, minimum value of y. X represents number of threads, y represents the locks. So as we have to find a minimum value, so here according to the options we can start with this one, x is equal to 1 and y is equal to 1, because this is the minimum. Then we can see whether it is satisfied or not, it is having deadlock or not. Let's say there is only one thread. Okay, now let's say T1 is the thread. Let's say it is acquiring some lock x. I mean, there is a semaphore, using semaphore it is acquiring the lock. Fine. Now some critical section is there, and let's say after critical section again, for some case it is again it again wants to acquire the lock. Okay, it again wants to acquire the lock, so again it is going to perform p of x. I'm just considering one case here. Okay, so we have one lock and we have one thread. So in this case, once it has acquired it, now if we are considering this one, in this case it will get blocked because the locks are non-reentrant. It cannot be acquired again by the same thread without releasing it. So yes, we can say if we are having one thread and one lock, then also possibility of deadlock is there, because it is saying non-reentrant lock. And other thing is, if a thread is unable to acquire a lock, it becomes block. It will get blocked until the lock becomes available again. So lock is not going to get available again, so that means this T1 thread will get blocked forever. If this T1 thread gets blocked forever, that means the entire process will get blocked. Yes or no? Is it clear, everyone? So the minimum value that satisfies this condition would be x is equal to 1 and y is equal to 1. Clear? This is the correct answer for this question. Okay. Fine. Let's proceed to the next question now. Question number 6. Total we have 8 questions today. So guys, try to answer this one. Question number 6. This is also not a difficult question if you can understand the meaning. Yes, everyone read the question, and guys keep sharing the session. Also, if you get any doubt, you can ask here. Okay, if you are having any doubt. Yes, what should be the answer for this question? Let's read the question. Consider the following snapshot of a system running n concurrent processes. Okay, n concurrent processes. Fine. Process I is holding xi instances of a resource R, where I is less than equal to n. Assume that all instances of R are currently in use. Further, for all I, process I can place a request for at most yi additional instances of R. That means, let's say we have one process P1, let's say P2 is there, P3 is there, up to Pn is there. Fine. P1 is holding x1 resources, instances of resources. P2 is holding x2 instances of resources. Similarly, this is x3 up to xn. Now what it is saying, that every process I can place a request for at most yi additional instances of R. That means P1 can place additional request of y1, it can place additional request of y2, y3 up to yn, Okay. while holding the xi instances already it has. That means whatever it is holding as of now, still apart from that additional these many instances it can request. Okay, of now out of this n processes, there are exactly two processes P and Q. There are exactly two processes P and Q such that yp is equal to yq is equal to 0. So here it is saying, let's consider one case here, that we have one process, let's say P, we have one process Q. Now it will be holding some xp instances of resource R, and this is holding xq, right, according to the question. But here it is saying that it is not requesting additional instances of R. So yp is equal to 0. Similarly, Q process also, it is not requesting additional resources. Okay, this is the meaning of the statement. Which one of the following conditions guarantees that no other process apart from P and Q can complete the execution? That means once P and Q complete their execution, then after that no other process will be able to complete their execution. Is it clear? So we have to find that condition. Now carefully see this. Once P and Q both complete their execution, that means XP and XQ will become available. So if I don't want any other process apart from P and Q to complete their execution, can I say the total resources we are going to have after P and Q complete their execution, that is XP plus XQ, it should be less than, it should be not equal to, it should be less than the minimum requirement we are going to have from all these processes. Yes or no? So minimum of yk we can say. That means whatever these processes, other processes are requesting additional number of resources, after having these free resources, still if we are not able to satisfy the minimum requirement, then can we say that all other processes will not be able to complete their execution? Yes or no? So that is why if xp plus xq is less than, that means whatever is the minimum requirement, that is also xp plus xq is also less than that. So in that case, can we say option A is the correct answer? xp plus xq, if it is less than the minimum requirement yk we are having, if this is the case, then in that case only P and Q have completed their execution, other processes will not be able to complete their execution. So that is why option A is the correct answer here. Option A is the correct answer here. Okay, any doubt, anyone? Guys, do reply in the chat box. Okay, if you have any doubt, yes, Meenakshi. Okay, do let me know if you have any doubt in the chat box. Okay. So option A is the correct answer for this question. Or if you want to consider the values also, let's say xp value is 2, xq value is 3. So total 5 instances of resources are free after PQ complete their execution. Now the minimum requirement of all other processes is, let's say, greater than 5. So can you allocate the resources required by other processes? No, because you have 5 and the requirement is greater than, the minimum requirement these processes are having is greater than 5. That means they will not be able to complete their execution. Only P and Q will be able to complete their execution. Clear? So that's why option A is the correct answer here. Fine. Let's move on to the next question now. Question number 7. Try to answer this question. This is GATE 2021, previous year question. Read the question carefully, and this is MSQ. This is MSQ question. Here also it is mentioned, is or are possible. So try to answer this. Yes, everyone try to solve the question. Okay. Read it carefully. So here it is saying, consider the following pseudocode where S is a semaphore initialized to 5. Initial value of semaphore is 5 in line 2. So this line 2, it is initializing the value of semaphore as 5. Counter is a shared variable. So we have one shared variable here. Int counter is equal to 0 in line 1. Assume that increment operation in line 7 is not atomic. This is your line 7. So let's assume this is not atomic. When it says not atomic, that means while executing this instruction at the assembly level, we can have preemptions. Okay, AB dividers is saying A, C, D should be the correct answer here. Okay. Fine. So line 7 is not atomic. If 5 threads execute the function perop concurrently, which of the following programs behavior is or are possible? So we are having 5 threads here. Okay. And this is not atomic. So let me write it at the assembly language code. So we can write here load. Let's say R0 is your general purpose register which you are using, and counter incrementing R0, and then store counter comma R0. That means we are loading the value of counter into R0, we are incrementing R0, and then finally we are storing the value of R0 into counter. So at the assembly level, this one instruction counter plus plus we can understand in this way, that it is this. Okay, clear? Tries to answer this one. Now, which of the following behaviors of the program is possible here? And we have 5 threads. Option A is the value of counter is 5 after all the threads successfully complete the execution. Is this possible? Is this possible? Now carefully say this. Yes, it is possible. How? Let's say thread, we are having 5 threads, T1, T2, T3, T4 and T5. Let's say T1 executes first. So let's say it is a sequential access. Okay, T1 will execute first, weight of S. So it will perform, let's say S is equal to 5 here, it will make it 4. Then weight of S, it will make it 3. Counter plus plus, it is going to increment the value of counter to 1. Signal of S, 4. Signal of S, 5. Right? And then T2 appears. So it is going to increment by 2. Similarly, T3, T4, T5. So at the end, yes, it is possible that we can have the counter value as 5. So option A is definitely the correct one of the correct answer. Option A is definitely one of the correct answer. Option B now. The value of counter is 1 after all the threads successfully complete the execution of perop. Is it possible that after completion of all the threads still the value is 1? Now let's consider that case as well. Fine, let's consider that case now. Let's say T1 starts executing, wait on S, it performs. Fine. So what it does, initial value is 5, it will make it 4, it will make it 3. Fine. Now counter plus plus, let's say load, it is going to load the value of counter, that is 0 here, increment R0. So R0 value will become 1 from 0. Just before it was about to execute this store statement, it got preempted. T1 thread got preempted here in the increment one. Okay, increment R0. Now let's say T2 appears. So T2 will perform wait on S. It is going to make it 2, it is going to make it 1. Counter plus plus, let's say it executes all the 3 statements. So it is going to make the value of counter as 1. Signal 2 and 3. Let's say T3 arrives. Same thing, it is also going to perform, make it counter plus plus 2. Then T4, make it counter 3. Then T5, it will also increment the value of counter as 4. Now let's say T1 comes back. So after this statement it got preempted T1. So what it does, it is going to store the value in the general purpose register, that is R0 of T1. What will be the value? Value is 1. So the final value it is going to load in the counter will be 1. So it is going to overwrite the value of counter as 1, and then finally it is going to perform signal of S, signal of S. So yes, it is possible that we can have, after the completion of all the threads, still it is possible that we can have the value of counter as 1 in this case. Clear? So that means option B is also possible. Option B is also possible. Is it clear, everyone? Is it clear? Now option C, the value of counter is 0 after all the threads successfully complete the execution of perop. Is it possible that we can have a 0 value and all the threads have completed their execution? No. The minimum value we can have is 1, and we have seen that case 0 is not possible in any case, because ultimately they are going to increment the counter, yeah, right? So option C is not possible here. Option C is not possible here. What about option D? There is a deadlock involving all the threads. So do we have any possibility of deadlock? Let's find it out. Let's find it out. So let's consider the values again here. S is equal to 5. Let's say T1 arrives, it is going to perform wait on S. Fine, it is going to make it 4. Let's say it got preempted just after this one. T2 arrives, again T2 will also perform wait on S, make it 3. T2 also got preempted. T3 arrives, wait on S, 2. T3 also got preempted. T4 arrives, wait on S, 1. T4 also got preempted. T5 arrives, wait on S, 0. Now T5 will execute wait on S. Already the value is 0. It will get blocked here. This is a counting semaphore. 0. It will decrement the value -1. So as we are going to have the counting semaphore value in negative, the process will be blocked. The process will be present in the waiting list. So in this case T5 will get blocked at this statement, right? Now let's say T1 arrives, same situation, it is going to make it -2, blocked here, T2 blocked here, T3 blocked here, T4 blocked here. All the threads are blocked in this case. So that means we can say that yes, a deadlock is possible in this case when every thread is going to execute this first statement and then it got preempted. In this case all the threads will get blocked here and deadlock is possible. So option D is also correct here. Thank you Priya for your compliments. Okay, so I hope it is clear. If you have any doubt you can ask. Let's solve the last question, that is from GATE 2022. Question number 8. Very simple question. I hope most of you will be able to answer this correctly. Yes, De Villiers, ABD is the correct answer. Okay, everyone try to answer this. Okay, just see the question carefully. Here just you have to find out the values of semaphores so that the printing sequence will be BCA, BCA and BCA, and it is going to continue like this. So what should be the values of semaphores S1, S2 and S3? Yes, everyone try to answer this. This is the question from GATE 2022. And I hope most of you will be able to answer this correctly. Okay, AB de Villiers is saying option C should be correct. Fine. Anyone else? C for Chennai. Okay. Let's see the question here. Consider the following threads T1, T2 and T3 executing on a single processor synchronized using binary semaphores variables S1, S2 and S3 operated upon using standard wait and signal. The threads can be context switch in any order at any time. Which initialization of the semaphores would print the sequence? This one, BCA, BCA, BCA and so on. So here, as you can see, first of all we need to print B, and you can see here T1 is printing C, T2 is printing B, T3 is printing A. So we want to start with B only. That means we want the execution to be start with T2 only. So if I want T2 to start the execution always, definitely this S1 value should be equal to 1 because we are performing wait operation on S1, so that it can print, it will perform wait operation, it will print output B. Now after B we want C to print. So if I want C to print, definitely this signal S3, so S3 value has to be 0. Similarly S2 value initially has to be 0 because we don't want in any case to print C or A first. We want only B first to print, and then we want this one. So obviously these are going to be the initial values 1, 0, 0. S1 is 1, S2 is 0, S3 is 0. So this will make signal it will signal the value of S3, wait on S3, 0, print C, C. Clear? Then in that case signal S2, it is going to make it 1, wait on S2, it is going to make it 0, and then print A. Then signal S1, so it is going to repeat like this, BCA, BCA and so on. So initial values should be S1 is equal to 1, S2 is equal to 0 and S3 is equal to 0. Clear? So that means option C is the correct answer for this question. Yes, option C is the correct answer for this question. Clear? So I hope guys all the questions and its solution and the explanation is clear to all of you. If you get any doubt you can ask, and if you get any doubt later on as well, then also you can ask in this Telegram group. So you can join this Telegram group. You will be getting the PDF of all my YouTube classes. Okay, and one more thing, on 27th of March we are having a Menti session on this synchronization. Menti session would be there, so I want most of the students to participate in this Menti session. Next subject कौन सा start करेंगे sir? After this one we will be starting C programming and data structure. That will be taken by Satya sir. Okay, clear? So this is the Telegram group, you can join. You will be getting the PDF of all my classes, doubt clearance and the guidance. So thank you all of you for joining this class. I will see you on 27th, and that will be a Menti session. So we are going to make it interesting for all of you, so that maximum students can participate and they can learn from here. And also if you don't want to miss any notification, you can subscribe to Byjus Exam Prep YouTube channel and also press the bell icon so that you don't miss any notification of our classes. Thank you all of you. Good night, take care and bye bye. Thank you.